Thank you, Mr. Chairman. First of all, I would like to express the thanks to Professor Takara for inviting me for this event. And I'm very glad to see that the new chair will be very much enhancing the potential UNESCO network in the sustainability science, I would say, because the situation concerning sustainability is complex but not hopeless. It needs a very, very intensive work, simply because we are using 150% of potential of our Earth. Ecological footprint is just increased to such level. And that's why it's not enough now to just only protect the environment. We urgently need to increase, enhance sustainability potential. And just this is only possible to the change of way of thinking from structure of nature protection to process regulation, by regulation and process. And processes can be only understood when we integrate different sciences, like a mission of the new center is holistic approach, and as Professor Takara underlined, there will be integration of this different discipline with big capital of knowledge which exists here. Okay, now why ecohydrology? Because ecohydrology is a so-called science which offer more for less. It means just less energy, less capital, financial potential, and more results. And I would like to try to give a few examples. So first of all, as I said, we already changed very much our biosphere, and we are not quite understand what we are doing with biosphere. And for example, solution like geoengineering to compensate global change is not really subject of trial and error approach, should never be, because we cannot transfer ourselves to the Mars or Moon. Okay, so, and ecology in combination with hydrology explaining why, for example, some process has a non-linear character, and understanding this is giving a fundamental to start to regulate system. And now, situation is complex because legal system, politics, and in the range of non-material values, moral and beliefs, changes much slower than economic processes. And especially environmental law, for example, and environmental knowledge about sustainability. So, and why water is so important? Because it's simple, major determinant of biopotential of biosphere. And this is an example from my Spanish colleague, Professor Lamas. What happens if the groundwater resources in Mediterranean climate were exploited too intensively? You see in the Niana Park. However, when they reduce exploitation by 30%, ecosystem recover very fast. In 3 years, you see we already have a bioproductivity, biodiversity return. So equilibria are very dynamic, and still we have big potential for regeneration. And this is showing that if we have a profound understanding, complex system, water, biota, society, we can really start to enhance potential. What we have done with climate and water nutrient cycle, because this is key for sustainable future as well. First of all, we accelerate water outflow to the sea from agriculture and urban landscape. And if the water become limiting, the acceleration outflow is not really a wise idea. By, for example, straightening the river, we change the carbon nutrient cycles, reducing organic carbon amount in catchment in the soils. Why? Because if we unify the landscape wind is accelerating, drying the soil, we are losing organic matter, which is slight fraction. And third element, these processes reduce the productivity, resilience, ecosystem, and other things, and we can see soil degradation in the world which is strictly dependent on the water resources and water retentiveness in the catchment. Climate change will make situation more complicated if we not change the pattern. And this is example from Europe. You see the economic kind of, let's say, lack of coherence European Union is generating like this. Agricultural farmers get money proportionally to the surface. So he clean up landscape from the all shelter belts, 3 rows, land water ecotones destroyed here with 3 roads. And in 10 years, he lost organic matter and get the sand like a desert. Organic matter go down, and eventually, because ecotone buffering zone destroyed, also nutrients which he's putting here, and rest of organic matter going to the river. And what he's doing? He's generating toxic algal bloom. Of course, this is not only Poland, this is Africa, Tanganyika Lake, and one of my programs. So it's broadly in this such a process appearing. So we have to keep in mind that if we want to keep the water and generally sustainability of catchment, we have to start thinking from the terrestrial phase of hydrological cycle. Because if we transfer these nutrients and organic matter, water resources are changing like this, and we are losing all the ecological services. So the problems can be, according prediction, gets worse and worse. So what is the problem? Sectoral approach, short-term benefits, long-term degradation. Is example, for example, like in Saudi Arabian exploitation non-available groundwater for wheat production in temperature 40 degree plus in the desert. This is a beautiful method evaporating of water and losing the treasure from this. The same, like I mentioned, this element loss of organic matter. And what in ecohydrology we're saying? How to regulate the system? First of all, always we need a model of processes. If we want to regulate, sometimes we have to understand how, according to specific of the typology of ecosystem. In this moment, typology is river continuum, different stream orders, and temperatures, different climatic zones, hierarchy drivers is changing. That's why, because there's no silver bullet approach, no one solution for all type of ecosystem. And this model is showing that it is possible, it is necessary in different phase of river, along the river continuum, different climatic, use completely different approach. For example, here is showing the river in Norway, in Scandinavia, the stocking of salmon. That has no sense because abiotic factors are so strong. The expenditure energy, according to because Bernoulli law, showing what happens there, is necessary to improve habitats. And this was implemented, this model in Norway, and 4 times fish productivity increase immediately. So theoretical model is a kind of way of ordering our thinking about the system. And if we want to start to develop the systemic approach, and system becomes more and more complicated because the man is diversifying, increasing impact and diversifying form of impact. In this moment is of course empirical elements are also important. Ecohydrology background was started from manipulation of water level, which demonstrate that change of hydrological pattern in the reservoir has a big consequences for biological structure and reduction of the zooplanktonnivorous fish dramatically increase resistance of the system to toxic algal blooms. And this was applied. This is model showing that in the river catchment of Pilica, algal blooms are proportional to phosphorus concentration in the river. Why? Because if it's wet year, lots of rain, lots of phosphorus coming. If it's dry year, less phosphorus and no blooms. However, when we manipulate water level, we increase zooplankton, biofiltration process, we reduce by half from biomass of algae. This project still is progress and further data exists. So in this moment, cost 0, only knowledge, understanding biota hydrology interaction can be, and many tools like this can be developed. So, of course, we now coming to the called nature-based solution, but fundamentals, of course, are Eco Hydrology, which already was defined as use ecosystem properties as management tool. And of course, in the context of catchment and use different nature-based solution has to be cumulated for synergy, because if we do not put the synergy in catchment, very often some elements can be not create positive interplay. The Professor Sven Erik Jorgensen, the very famous ecological modeling specialist, Stockholm Water Prize winner, in his paper said the ecohydrology building the bridge between ecology and environmental management. Yes, I think it's building the bridge because, of course, still underlying that hydrology is fundamental element of the system, because abiotic factors are primary of importance only when becoming stable, predictable, biota can manifest themselves. So without hydrological background, we cannot really work too much. And three principles which were mentioned, this is element of the story. Always we're starting from quantification of processes, hydrological processes, quantification of impact, distribution, spatial distribution, next distribution of ecosystem, which can be used as a tool for reduction of impact, and ecological engineering for this. So, however, ecohydrology also generates new tools, completely innovative tools like biotechnology, because this provides knowledge how to convert form of matter for improving water quality. Why conversion of form of matter is important? Because simply all processes, not only acceleration, water will flow from the catchment now, and evaporation, but second element, we convert organic matter in biomass and in the soil into CO2, for example, yeah, and reducing, and this moment change allocation of carbon. And just understanding this method and use microorganism phytotechnology, we can reverse the negative process. So we can use molecular biology for early warning, cause-effect analysis, analyze relationships, and biotechnologies. For example, one of example which we're working now when we discussing about the, for example, sediment reduction or organic matter transfer is analyzes how different strains of bacteria can convert the carbon to CO2. Some places we don't need servicing of our purification, the hydrological system, because if we amplify the process to a certain extent by selection bacteria. First step, enhancement of natural ecosystem. Just using phytotechnology, changing the biological structure, we can almost double trapping of phosphorus in the catchment. And 1 kilogram of phosphorus is converted in 2 tons of algal bloom. So this is really important to combine such elements. And second element, we have 2 different fluxes of nutrients. Agricultural land usually generates lots of nitrogen, and human settlements phosphorus, which immediately generate beautiful algal blooms. And we develop some high efficient barriers. Here with denitrification barrier is different bacteria enhancement, and here geochemical barrier combined with this. Of course, geology and barriers are composed in the system, so there is not visible. And this is denitrification barrier, where the nitrogen is reduced in up to the 90%. So what one of the advantages is ecohydrology. If we express human impact as the concentration of phosphorus in the river, 10 is a sewage from the city, for example. 0.3 is natural background in primeval forest in Europe. In this moment, such a natural system has resistance 3 times to the level of what today I asked Professor Yamashiki. However, by technology, we're focusing on reducing the impact from sewage. But this was a gap between sewage, usually have a 1-2 milligram of phosphorus, and natural fluxes from the agricultural landscape urban stormwater has around 1.05, and this was gap which provide more than half of load to the reservoir to the sea. So without taking care about this element, even distillation of sewage never will be efficient, and that's why ecohydrology is filling the gap between technology and natural resistance of the system. Okay, so second element, as I said, we need to retain the water, but not by classical way, because stopping a river usually have many negative aspects. But this is example when the small city near Łódź, the mayor asked me if this reservoir is planning on beautiful wild meandering river, which we have a beaver and other very important animals, can be built without, because there does not exist algal bloom danger. Of course, after measuring, I said definitely will be blooming if you build like this. But I can tell you how you can build without destroying the natural river and maintaining natural river, and you can build on the floodplain as side reservoir. Additionally, here is not only a sequential biofiltration system, recreation area, but also special system which is only releasing the clean water, because quality of water is oscillating. So when water is clean, electrodes are measuring and putting in reservoir clean water, but water with high phosphorus is going still phosphorus is not toxic for fish. If oxygen is, that's okay, but it's converted phosphorus here in toxic algal bloom. So in this moment, we can combine many elements. We improve water resources because we increase retentiveness of river valley for drought period compensation. Second, biodiversity, because in this moment, some wetlands, by the lifting up groundwater level, we're recovering, and also some spawning place appear here. Ecosystem services, because we provide recreation area. Additionally, I propose here to build up the education center, because society education, that was in this first lecture, this session, is fundamental to implement such systemic, complex approach. Society must understand at least what they can achieve from system and that there are certain limitations. And finally, resilience to climate change. This reserve, the capacity of water here is 3 times more pumped in groundwater system. So it's, if we build on the river, for example, this is not big river, if we build 14 such small dam, there will be completely adaptation, the effect of any scenario climate change will be not dangerous, because in this moment we already make some modeling. And finally, culture education. This is a center for education, and I propose to not only give opportunity to see the wild river here, but also put part of the wild river to the big aquarium to show the people how river looks from the this. So city, now very quickly, city of 21st century, city of the future. This is very important that we have in Europe big problems with water quality. All Europe, there are heat islands in the city when they are just, we generate asthma allergy. This is one of the systems which was built in my city after constructing eco-hydrological sequential system. This is, and why we build? Because when we analyze alpha benzopyren, it shows that if it's less than 20% green area and no water in the landscape, alpha benzopyren is 3 times higher than in area where it's minimum 30% of the green area with some retained water in the landscape. And in this situation, also the allergy asthma among children is 3 times higher in such area with this pollutant. So city planning has to incorporate, like in Malaysia, the water as a treasure of which determine quality of life. So this is a approach when in the past there was bottom-up, mostly infrastructure element which was critical for design of the city. Top-down, the man, his well-being is already key element, and this is concept blue-green network for city of Łódź, which is on the age of two catchments, so water is rather limited, and only small rivers from the past which are containing small water. The construction of sequential system or high efficiency allow to construct such small reservoirs. And what is the beauty of this? Because in constructed wetland, classic constructed wetland needed 3%, 2% of catchment to really work. However, here is only 0.3% because processes are so intensified and they are all processes which naturally appear in the river. This is only very compensated in the small place. Of course, sometimes are enforced by in hybrid system by engineering solution. So that some system looks like this in the city. Before constructing some system on all this river was recovered, and after construction this efficiency. Here is entrance, concentration of suspended matter, this outside. What is important, the highest efficiency of purification is constructed this way. There is most efficient if high concentration coming. Low concentration of pollutants are less, which is not important because they are not so dangerous. And just below we have such reservoir. Okay, the second step, we had a cascade of the reservoir in the forest, which was blooming permanently, as I show picture. We construct here some hybrid system when the big fluxes were coming. And eco-hydrology here was combining engineering enforced by a eco-hydrological biofiltration system with some geochemical barrier, some geotextile specially constructed by Technical University, biological, but also increase resilience again by shaping fish community, which is just many predator reduce zooplankton fish, and you see this middle of July and the water is absolutely clean. This is some way the many elements of the encatchment was used in this EHREC European project, and there's some elements. This is a cascade of reservoir, and as I said, the most important is that 20 years ago, limnologists were saying that if lowland reservoir is blooming, there is no chance for recovery because catchment surface is so big that it will be no. And this, as we see, we succeed that using this solution, especially putting in the system according principles of ecohydrology, it works. And I will be a little bit imprudent. This project get best of the best live project among 60 granted project, and application probably was 600 now in European Commission last year. And project Ecorop about agricultural landscape was among 10 best projects. So of course we're going further, more complicated, more advanced, I would say. Here loads are more higher and protect the river. I think there was efficient. We developed this with company, and company was so satisfied that already bought from us a patent for this type of solutions. And of course we can develop some for sustainability systemic solution. Small sewage treatment plant was not efficient. We provide the sewage as fertilization for biogen energy plantation, create employment opportunity. We use the fossil fuel. We create employment opportunity, improve water quality. This is something when it's process-oriented thinking generate the combination different elements involving society in this. Of course, molecular biology, this is element, as I mentioned, important. This knowledge is translated also to Ethiopian conditions. In Ethiopian program, this is for Lake Tana analysis of the threats, some adaptation of the system. I will not go details. And from the point of view economy, because economy is always important. You see, using only engineering solution, we never will get this good ecological status, simply because diffuse pollution. However, they are very important. However, they have to be combined with eco-hydrological and biotechnological elements. In this moment, we can, at moderate cost, achieve really much better status than only purely in hydroengineering. Finally, when we are talking about education, I think education may be on the end. Somebody can take into consideration. We not only should teach information, but also knowledge, theory of understanding pattern processes, experimental testing, and translate to wisdom. Use information knowledge to problem solving. And this is something which such transdisciplinary science has to be done. What means how evolution of the approach goes from the structure-oriented to problem-oriented. Conservation, maintaining status quo, restoration enhancement, let's say highly degraded area, ecological engineering, design ecosystem for mutual benefit, eco-hydrology, regulation, water biota interplay for enhancement ecosystem potential, all catchments still considering conservation, restoration, ecological engineering solutions as element. And from the point of view, the diversity of scientific approach which exists, hydrology putting this into as a background for systemic solution. So, conclusion, eco-hydrology, by integrating knowledge, have been providing new dimension. Innovative technologies, dual regulation, biotechnology, hybrid system, civil engineering, systemic solution for enhancement, catchment, sustainability potential. Thank you very much for your attention.